Assalamu alaikum everyone. My name is Muhammad Sami. I'm doing Lab 1 assessment for COA subject. So this is simply Lab 1 where I was responsible for doing uh, Lab 1A and Part 1C. And now Part 1A and Part 1B. And now I'm going to record for both A and B. So basically, Visual Studio, we're using the 2019 version. This is 1A. So for 1A, there's nothing here. We're just gonna record the, we're first gonna build it. We're gonna build the lab work. And as you can see, it shows there's no issues. I'm gonna control S, sorry. I'm going to rebuild it. Okay. So it shows one successful, zero failure. That's great. And now I'm gonna go debug the lab work. So we're gonna see the result in the terminal now. Okay, that's the results. We don't have any problems with debugging, but in the assessment we need to do the 1B and 1C. My friend in the team did 1C already, so I'm going to do 1B. So let's go ahead and run Visual Studio again. And I'm gonna go to run 1B as you can see here. All right, so we're gonna try to start now. Perfect. First of all, I will rebuild the lab work to make sure that there's no issues. So we have one successful building, zero failure, zero skipped. And then I'm going to start the debugging. Okay, so this is the debugging starting. All right, we did debug and the EAX value shows this number. Now we're gonna go ahead and skip step over, which is F10. Once we step over, this is the values. We can see the values here. We have the, sorry, I have to click view as this is simply code here. So we're required to show the windows. We're gonna show the autos. We're also going to show the memory. It's already here. We have the autos as well down there. We have the locals and the watch as well. So we need to trace these items, but it's already being traced. But let's go ahead and step over one time, F10. Now, if we step over here, it shows us the value of EAX. As you can see, this is the value of it. And now if we step over again, which is value 1, this is value 2, okay? And it's stepping over again. In the memory, I will look for value 1. Yes, okay. So this is the address, sorry, the address is going to be val 1, for example. Yeah, this is the address for value 1. And now let's step over again. This is the value for value 2. Step over again, the value changed here. And as you can see, this is the value. And then we should end up with we started with this number. We added this number. We subtract this number. And now if you click again, we should get this final value over here. Okay, that's it. We're gonna, in the last thing, we're gonna display the registers. And now as you can see, this is the final value is changing now. Before it was 0, now it is changing to this value right now. Click F10 again. That's it. We need to push and then exit the program last time. That's it. So this was for the lab 1B basically. That was the debugging. That's it. Assalamu alaikum wa rahmatullahi wa barakatuh.
Hi, my name is Adishwara Alaki Mahindra. Today I'm going to present my Lab 1C and my matrix number is A23CS8021. So my Lab 1C is add and subtract. So this program will add and subtract 8 and 16 bytes. So the data here is while W1 is 1000H, while W2 is 4000H, while W3 is 2000H, and we need to find the final while W for the 8-bit. Then I will go for 16-bit, which will be while B1 10H, while B2 byte 40H, while B3 byte 20H, and we need to find the final for while B byte. So the code will be, I just added in the one additional code to clear all the 32 bits. Then the first one will be move. They will start with 10,000. Will start with the 1000H for while W1. So then it will add 4000H. Then it will subtract 2000H. So we'll get the final value. It will show the final value. Then it will call the dumb racks to register to display the registers. Then for this 16 byte, it will show well B1. So it will start with 10,000 H or 1000 H. Then it will add 4000 or 40,000 H. Then it will subtract 2000 H. Then the final B value would be the final result of the add and subtract. Then finally it will call the dumb racks. Then we'll exit the debugging. So let's start debugging here. Alright, so for the first step, let me clear the register. So now the register EAX is showing 0019 FFCC. So I'll clear the register. So it becomes 00000. So now for the watch, we'll see. Now we are going to start with 10,000, 1000 H, and the memory is over here. So 10, we'll show here 10. So we'll start with 10 over here. So now the register is updated where it shows 1000 in the register. Then in watch 1 we are already in the first place here. Then for memory we are at here. So then when we add 4000H, the value for EAX changes to 0005000, while the watch will update to the second area here, and the memory will go this one. So when the next we debug, we step over again. For subtract, it will subtract 2000, which the which the result will be 3000. So for the final value, we'll move to the final value now, where the watch is now at WAL W3. So the final value is now 0000 in the watch and the memory is over here. You can see 10, 10, 40, 20, then 0, 0, 0, 0. So now the final value in the autos are 0 times 0, 0, 0, 0, 2. So now if I step over again, debug again, the value doesn't changes in the register, but in watch 1, you can see the final value for this one has changed to 0 times 3000. And in memory 1, you can see there's 30 over here. It has added, the memory has been updated. Then in the autos, you can see too the 0 times 3000. So this one is the final WAL W for 8-bit. And now we will go for 16-bit, which we can see. So for 16-bit, it will start with 3000. Then it will update again where we move to the AH where we start with 10,000 H. So the EAX shows 1000, 000, 1000, where the watch one is now over here, and the memory is starting from here. So now if I step over again, and it adds 40,000 H, where the result will show 0000 5000, and the watch one is now in val B2, and memory is over here right now. Then when I step over again, the register shows the result after being subtracted 20,000 H. So the result is 00003,000, and the watch one is now in this step, and memory is over here. So after it subtracts 20,000, so now the result over here is still empty in the memory. The memory has not been updated yet because we not yet get the final val B result. So in watch one also it shows for final value B, it shows the 0 times 00 value. So right now in the autos you can see the value here too. So now if I step over it again, so these are the result for final value B, which is 00003,000, and in watch 1 you can see the final value has been changed, and in memory it also has been changed to 30, where in the autos it also been changed to 30. So so the register here, it already been add, subtract, and it has been stored the result for the register. And I guess that's all from me for this lab 1C. Thank you. So and finally we just end it. So we can see the final value B over here is 30. Same goes to watch, register, and memory. So these are the memories. So the first, so this one is the value for the memory from 8 bit, which is the 10, then add 40, then subtract 20, then the final uh, well the final val w result is here. So here is the result for valve B. So this one is the valve B1 where it starts with 10. Then valve B2 where it's at 40, so it changed to 40. Then this is subtract 20. Then the final valve B result will be 30. So that's all from me. Thank you.